Good morning. Today we're working on what I refer to as tricky vectors. And so you look at the screen here. Let's just kind of look at our sample problem. So Bob walks 5 meters at 36.9 degrees north of east. And then he turns and walks 6.34 meters. 6.34 degrees north of east for another 9.055 meters. What's his overall displacement? So what's happening is, let me just get the highlighter. Bob starts here. We do 36.9 degrees north of east. That's on this side of it. And he goes 5 meters. Then he changes his attitude and walks just 6 degrees north of east. And he does this for 9 meters. Okay. And what we want to find out is switch colors. What is the overall displacement is what we really want to find out. So hit reset. To do this, you need to take these vectors and you need to break them down into their pieces. In the previous chapter, if we had, for say, 2 accelerations and 2 times in a problem, that meant we had 2 parts of the problem and we had 2 calculations to do. Well, that's kind of how this is as well. If you've got 2 vectors, you probably have 2 sets of calculations to do, and then you can combine them. So this one, which is 5 meters at 36.9 degrees, that means Bob walked sideways and up. He went, my coordinates are north and east, so he went east and north. And then Bob did another move, and he walked a great deal east and a little bit north. So we see these blue lines. Now it's time to use the SOHCAHTOA to figure out what these blue lines are, because we can solve right triangles. Once we solve these right triangles, we can say, so Bob walked east this much and this much. Bob walked north this much and this much. Now we have one big right triangle that we can solve. The blue and the red gives us the answer. But first things first, we have to break down these individual triangles. So, breaking down the individual triangles. If you put in your calculator, you use some SOHCAHTOA, and you go here and you say that the cosine of 36.9 degrees times 5 meters, which is your hypotenuse, right? Here's 5 meters is our hypotenuse. Well, not the whole thing. 36.9 degrees is your angle, right? When you put in your cosine, you're going to find this adjacent here. And let's call this one, let's call this over here, let's call it x1. Okay? That would find x1. And then over here, we would find y1 using sine and cosine. So cosine is going to be x1 because it's the adjacent. And so you put that in the calculator, and I'm fairly certain that that's going to come out to a big old 4 meters. And then you use sine. You're going to say the sine of 36.9 times 5 meters gives us, and I'm fairly certain this one's going to come out to 3 meters. Because this is your classic 3, 4, 5 triangle. So that's part of the puzzle. Next, we have to solve for x2. That's this line here. And again, let's see, we've got 6.34 degrees for our angle, and we have a hypotenuse of 9.055. So again, we're going to use cosine to find x because we have adjacent over the hypotenuse. And so you hit cosine of 6.34 degrees. You multiply by the hypotenuse of 9.055 meters. And this one comes out to 9 meters. And then again, we got to do this one over here. Let's call this one y2 because this is triangle 2. And use sine of 6.34 times 9.055, and this is going to come out to 1 meter. And so you got those calculations, and that gets you halfway there, but you're not done. Now we got to figure out the big triangle. So at this point, we are allowed to ignore these two angles. They're no longer useful. We can even ignore these hypotenuses. They are no longer helpful. Now what we want to know is can I grab just these three? Nope, grab too many things. We want to know, overall, we went up 3 meters and 1 meter. Overall, we went sideways 4 meters and 9 meters. Okay? Not 14. Make sure we're saying 4. 4, 9. So overall, we went sideways 13 meters and we went up 4 meters to make the big triangle. We can solve a 13 by 4 triangle. Here, let me tap out some numbers here. You tap out some numbers too here. Let's see. 13 squared plus 4 squared equals. Did you do that? Do you have this number on your calculator? Because my calculator says 185. And then I'm going to hit the square root. No, wrong button. Clear. The square root of 185. And I have an answer. Do you have an answer? Okay, here we go. 13.6 is what my calculator tells me. This would be the overall displacement. So, in review, to do this, we've got to... Whoa, too many things moved. To do this, we've got to take each vector, like this here, this vector, break it into x's and y's. If it's crooked, break it into x's and y's. Take this vector, break it into x's and y's, and then we are allowed to mathematically combine x factors and y factors, and then we can use things like Pythagorean theorem to break them down. So after this, I know that sometimes the homework assignment that you were asked to do can be tricky, and so I'm going to give you just like a framework of the problem. So let's see here if I can remember what the problem says. The first one, I believe, talks about a guy running on the football field, and he runs. That's not the one I want. He runs he runs forward, and he goes to the right of his forward path. So this dotted line represents the forward path. He goes off to the right of it by whatever degrees. I can't remember that right now. Overall, you are searching for this line. Don't draw it in yet, because this is a y vector. That's pretty easy. You just add that on. But this one's crooked. So I said, take your crooked vectors and combine them. So he went forward and right. So you can find these using the hypotenuse and the angle. Once you have these factors, you can then say, oh, well, now that is a y and an x. That gives me a real nice triangle to work with that I can solve. Okay. Another problem is, let's see, I forget I think it's a rodeo clown running. He runs north, he runs to the northeast, and he runs to the east. And so you got a y vector, you got an x vector. That's not so bad. It's this crooked one you had to break down. Break this crooked one down into an x. No, I don't want that. Break it into an x and a y. Now you can say, oh, I got a y and a y, an x and an x. Now I don't want that one, I want this one. Now I can make a big triangle out of it. Okay? But you got to do your SOHCAHTOA for this one, and the placement of this angle is critical to get it right. If memory serves, it says north of east. So it's down here is the angle. Okay? Which, if you knew your geometry rules, you know that the placement of these triangles has the exact same meaning as the placement of this triangle. Okay? And then the third one, I get a lot of people who want to crash the airplane in the third one. So, and I want the black arrow, please. There we go. So you start off taking off at a very steep angle, and then once you reach a certain altitude, give me this line. Once you reach a certain altitude, you kind of level off a little bit, but you're still going up. Because people say, oh, however many degrees to the horizon. Everyone wants to like crash the airplane. No, don't do that. You're still going up, just not as much. And so this was just like the sample we did together there a minute ago, where you go up and over, and then you go over, and you go up. And you got to find those red vectors using SOHCAHTOA. And then once you have the red vectors, you can begin to create the big triangle. I move this one over here and bring this one down and this one down, because you're allowed to move them without rearranging them, and you can make the big triangle. Okay? So I hope that's helpful. Good luck.